Finding the right solution for labs' COVID-19 testing needs can be a difficult decision. The challenges are unprecedented and the options can be overwhelming. PerkinElmer was one of the first organizations to develop and deploy diagnostic tools in response to the disease outbreak. I would like to take this opportunity to share our experience in assisting labs on the front line of fighting the virus. Depending on the desired outcome for the lab, one or more complementary detection methods can be employed. Real-time PCR assays are used to identify SARS-CoV-2 RNA shed by individuals with an active infection. The results are typically used to determine treatment and quarantine plans. On the other hand, immunoassays detect antibodies to SARS-CoV-2 that have been reported to appear days after infection and persist for a relatively longer period of time. Immunoassays are a valuable set of tools for identification of individuals who have developed an adaptive immune response, detection, and disease surveillance as well. The viral dynamics of SARS-CoV-2 is not yet fully understood. There is evidence that viral load tends to correlate with the severity of infection. Reports also suggest the possibility of SARS-CoV-2 transmission from persons who are pre-symptomatic or asymptomatic. A highly sensitive diagnostic assay with the ability to detect low viral load is thus required to accurately detect the virus and assist in preventing the spread of infection. Automation and assay controls are also effective tools to ensure robust results. Labs have reported that supply chain interruptions have had a significant negative impact, resulting in delayed results and decline in requests received over time. Vendors with a steady supply chain and a transparent view into their supply chain should be prioritized. Materials can be directly sourced from manufacturers who meet these criteria. Many labs also plan to increase capacity by adding platforms, shifts, or expanding their workforce. Modular automation can help labs adapt to variable sample throughput and reduce exposure of staff to the risk of lab-acquired infections. Testing is a complex multi-step process. Suppliers offering a comprehensive ready-made solution to implement automated SARS-CoV-2 testing can simplify life for a lab and the lab manager. Consolidation to an appropriate vendor can improve procurement efficiency and visibility to availability status of specialized reagents and equipment. Lastly, the quality of support can be the difference between success and failure for a lab. A responsive support team can help guarantee a better experience by assisting in every step along the way, from installation to analysis. Labs should work with suppliers they trust. The most common methods for viral identification are based on nucleic acid or immunoassay detection. Nucleic acid-based detection using real-time PCR is widely used as the method for diagnosis. At a high level, there are 3 steps in the nucleic acid testing process, which are sample collection, sample isolation, and nucleic acid detection itself. The preferred methods for sample collection at this point is oropharyngeal swab, nasopharyngeal swab, or anterior nasal swab. The Chemagic 360 platform is PerkinElmer's magnetic bead-based isolation method that is ideally suited for automated sample processing, which our customers have communicated as being extremely important in such emergencies. Sample isolation, plate setup, sample reformatting, and PCR setup can be facilitated by modular PerkinElmer JANUS workstations. The automated processing culminates in the detection of the virus using PerkinElmer's real-time PCR kits. Just as an example, labs that are processing up to 6,000 samples per day with a setup comprising 4 Chemagic 360 units, 3 JANUS liquid handlers, and 2 RT-PCR units. This sample capacity can be scaled up or down as this is a completely modular setup. The heart of this workflow is the real-time PCR assay. The PerkinElmer New Coronavirus Nucleic Acid Detection Kit uses Tachman-based real-time PCR technique to conduct in vitro reverse transcription of SARS-CoV-2 RNA, DNA amplification, and subsequent fluorescence detection. The assay targets specific genomic regions of SARS-CoV-2 namely nucleic acid N gene and ORF1AB, and leverages multiplexing capacity to enable processing of 94 samples in one run alongside a positive control and a negative control. The assay includes an RNA internal control that leverages bacteriophage MS2 to monitor the process from nucleic acid extraction to fluorescence detection. The internal control probe is labeled with Vic fluorescence dye to differentiate its fluorescent signal from SARS-CoV-2 targets. The Tachman probes for the two amplicons are labeled with FAM and ROX fluorescent dyes respectively to generate target-specific signal. The assay has been optimized to produce results with high analytical sensitivity and specificity. The results confirm a limit of detection of 7.142 copies per mil for the ORF1AB target and 23.380 copies per mil for the N target in oropharyngeal swab matrix using the Chemagic 360 platform. The results also confirm a limit of detection of 8.323 copies per mil for the ORF1AB target and 27.246 copies per mil for the N target in nasopharyngeal swab matrix using the Chemagic 360 platform. The viral DNA RNA 300 kit H96 is designed for automated isolation from 300 microliters of oropharyngeal swab, nasopharyngeal swab, anterior nasal swab, bronchoalveolar lavage, sputum, plasma, or serum using the Chemagic 360 instrument equipped with a Chemagic 96 rod head set. The isolation process takes just 60 minutes for 96 samples, following which the eluted SARS-CoV-2 RNA is ready for subsequent analysis using RT-PCR. The full solution for viral isolation comprises the Chemagic 360 instrument, the Chemagic 96 rod head set, and the Chemagic viral DNA RNA 300 kit H96. The 96-well plate format is well suited for high throughput nucleic acid isolation, offers reliable protocols for multiple applications, as well as convenient sample loading and online buffer dispensing. The Chemagic 360 uses transiently magnetized rods to attract the beads after binding to the nucleic acids. This feature and the concerted rotation of the rods allow optimal sample mixing during the homogenization and washing steps, thereby increasing the yield and purity of the extracted nucleic acid molecules. The transfer of the magnetic beads between the tubes minimizes the possibility of sample contamination between purification steps. The liquid handling steps are met by two configurations of the JANUS instruments. The first configuration is an automated alternative for a laborious primary sample reformatting process. The instrument increases sample processing efficiency by reformatting 192 samples in 48 minutes. It also reduces exposure from hazardous sample handling and improves sample integrity by reducing manual errors. The second configuration of the JANUS instrument aids in increasing efficiency by preparing 2 PCR plates in 16 minutes. The instrument reduces hands-on time and, like its sample reformatting counterpart, improves sample integrity by reducing manual errors. PerkinElmer has set up manufacturing lines across the globe to meet the growing demand for nucleic acid testing and mitigate logistical challenges in getting kits to our end users. The SARS-CoV-2 real-time RT-PCR assay manufactured in Finland. It's a CE-marked real-time PCR technique to conduct in vitro transcription of SARS-CoV-2 RNA, DNA amplification, and fluorescence detection. Each kit has 4 components with materials to process 96 samples in approximately 60 minutes using 14 microliters of extracted nucleic acid as input. The assay includes probes for human RNA target that's used as an RNA internal control to monitor the process from nucleic acid extraction to fluorescence detection. This test is marketed as an in vitro diagnostic device by meeting the requirements of the European In Vitro Diagnostic Directive. The kit manufactured in our factory in China is listed on the WHO procurement list. The emergency use listing can be leveraged by other international, regional, and national procurement agencies until April 2021. Our factory in Germany manufactures and supplies a completely independent line of RT-PCR kits, adding to the supply chain resilience. So far in this session, we reviewed nucleic acid-based detection methods. COVID-19 infection can also be detected indirectly by measuring the host immune response to SARS-CoV-2 infection. Serological diagnosis is an important method for patients with mild to moderate illness who may present late beyond the 2 weeks of illness onset. Serological diagnosis is also becoming an important tool to understand the extent of COVID-19 in the community and to identify individuals who are immune and potentially protected from being infected. As seen in this plot, IgM and IgG seroconversion occurs in most individuals between the 3rd and 4th week of clinical illness onset. Thereafter, IgM begins to decline and reaches lower levels by week 5 and almost disappears by week 7, whereas IgG persists beyond 7 weeks. Several studies suggest that IgG antibody to SARS-CoV-2 may represent the primary humoral immune response protecting patients against SARS-CoV-2. IgA, which is not captured in the figure here, has been shown to have a positive correlation with COVID-19 severity. The first seroconversion day of IgA has been reported to be 2 days after onset of clinical symptoms, thereby making this a strong early diagnosis marker. There is a wide array of technologies available for antibody detection. The underlying methods fall into 4 broad categories from PerkinElmer, as you can see here. Depending on the desired outcome and the lab's preference, one or more complementary detection methods can be employed. SuperFlex is a CE-marked automated chemiluminescence analyzer capable of detecting IgG antibody in up to 12 samples simultaneously in 15 minutes using serum, plasma, or whole blood as input. Coviscreen is a CE-marked lateral flow-based assay capable of detecting total antibody, including IgG, IgM, and IgA, in 20 minutes using serum, plasma, or fingerprick whole blood as input. GSP Delphia is a CE-marked time-result fluorescence-based assay for detecting IgG antibody in up to 5,000 samples every day using dried blood spot or serum as sample type. Immunoassay is a CE-marked laser-based method for detecting IgG, IgM, or IgA antibody. To narrow down the choices based on the lab's needs, it might be helpful to read this table from left to right, row-wise. If a lab is looking for a fast assay, SuperFlex or Coviscreen might be the assay of choice that offer 15 and 20-minute sample processing time respectively. Labs that are looking to process high sample volume in any given day might choose the GSP Delphia platform that enables processing up to 5,000 samples in a 24-hour day. All the platforms listed here can detect IgG, but if a lab is looking for IgA in specific, then Coviscreen and Euroimmune platforms are ideal choices. And if a lab is looking for the nucleic capsid protein, then Euroimmune offers that choice as well. In terms of sample types, GSP Delphia and Euroimmune offer the unique differentiation of allowing dried blood spot as a sample type for antibody detection. Lastly, all the platforms here are CE marked, with Euroimmune platform being FDA EUA approved as well for IgG detection. From here on, we'll take a few minutes to look at each of these platforms in a little bit more detail, starting with the SuperFlex platform. The SuperFlex anti-SARS-CoV-2 IgG kit is an immunoassay intended for qualitative detection of anti-SARS-CoV-2 IgG in human serum, plasma, and venous whole blood on automated chemiluminescence analyzer. This test is intended for use as an aid in identifying individuals with an adaptive immune response to SARS-CoV-2, indicating recent or prior infection. A specimen is added to a specimen well and then bound with magnetic particles coated with SARS-CoV-2 antigen. After washing, a plutonium ester-labeled anti-human IgG antibody is added to form an immunocomplex. The whole device is composed of sample loading module, reading module, magnetic bead processing module, and reagent strip loading channel, control system, and software component. So it's an all-encompassing system. Reagents required for sample processing are supplied in the form of a preloaded cartridge offering hands-free processing after initial sample loading step. The user can choose to load up to 24 samples in one batch or in smaller batches without having to wait for sample processing of the previous batch to complete. Fast sample processing with minimal handling and random access makes the system an ideal screening tool for labs. Moving on to Coviscreen. As we briefly touched on earlier, IgA has been reported to be an important diagnostic marker. In a significant proportion of patients, the IgA antibodies appear almost simultaneously, and more importantly, IgA isotope appears first with very high titers. There are studies showing that the combination of IgA and IgG, or IgA, IgM, and IgG, provides improved diagnostic reliability as compared to conventional IgM-IgG combinations. In addition, it has been observed that IgA levels in serum correlate positively with COVID-19 severity. These findings make a compelling case to consider an IgA-based antibody assay that also contains IgM and IgG as a companion test to complement RT-PCR. Coviscreen is a qualitative double antigen sandwich immunoassay for the simultaneous detection of total antibodies, including IgG, IgM, and IgA, to SARS-CoV-2 virus in serum, plasma, and whole blood. It is used for screening or to aid in the diagnosis of COVID-19 disease and exposure to the virus. And the total antibodies are specific to spike protein of SARS-CoV-2 virus are detected in this test. Coviscreen utilizes the principle of agglutination of antibodies with respective antigen in immunochromatography format, along with the use of nanoindicator colloidal particles as agglutination revealing reagent. Recombinant antigens specific to SARS-CoV-2 are coated in the test region or T region as indicated here, and biotinulated bovine serum albumin as assay control in the control region or C region as indicated here. As the test specimen flows through the membrane assembly within the test device, the colored SARS-CoV-2 specific recombinant antigen indicator colloidal particle complexes with the SARS-CoV-2 antibodies if it is present in the specimen. This complex moves further on the membrane to the test region where it is immobilized by the SARS-CoV-2 recombinant antigens, leading to the formation of a colored band in the test T region, confirming a positive test result. Absence of the colored band in the test region indicates a negative test result. The unreacted conjugate and unbound complex, if any, along with the streptavidin colloidal gold conjugate, move along the membrane and are subsequently immobilized by the biotinulated bovine serum albumin coated at the controlled C region, forming a colored band. The user should always look for a C region because the absence of the C region band invalidates the test results. We will now spend a couple of minutes talking about the GSP and Delphia platform. Three independently powerful tools come together here in this case to make an even stronger antibody detection platform for high throughput labs in the form of GSP Delphia anti-SARS-CoV-2 IgG kit. The three distinguishing characteristics being dried blood spot as sample type, the GSP instrument itself, and time result fluorescence technology. Dried blood spots have been used in large-scale population screening programs since the 1960s. The dried blood spot samples typically reduces cost and logistical constraints associated with collection, transportation, and processing of venous blood samples for SARS-CoV-2 antibody testing. These sample types make it easy to sample from finger prick using small volumes of blood that are easily shippable in an envelope at room temperature. For context, every year close to 15 million newborns are screened using over 500 GSP units that are in operation across the globe. Coupled with highly sensitive and robust time-resolved fluorescence, the GSP Delphia IgG assay offers tried-and-true technology for high-throughput, fully automated, and traceable sample processing for qualitative detection of IgG against SARS-CoV-2 using human blood specimens dried on filter paper and in human serum to ultimately aid in identifying individuals with adaptive immune response to SARS-CoV-2, indicating recent or prior infection. Lastly, for users interested in an immunoassay designed against the nucleocapsid protein, the PerkinElmer Euroimmune ELISA assay provides this option as well. N protein represents the most immunodominant antigen of the coronavirus family. In the interest of optimal performance, the Euroimmune ELISA assay is designed based on choosing only the diagnostically relevant epitomes as opposed to the full-length N protein. Euroimmune ELISA assays for IgA and IgG designed against the S protein is also available for users. To summarize, the critical considerations for choosing an assay include evaluation of the lab's needs, assay performance, availability, throughput, supply management, and support. PerkinElmer's SARS-CoV-2 detection platforms takes all these factors into consideration and offers a broad range of options for users. Thank you very much for your attention.